Good morning, and I want to express my deep gratitude for AAPQ for the invitation to speak today. I've been discussing with Jonathan LaPalme for some time these ideas of degeneration and regeneration and the commonalities amongst various disciplines and the ways in which so many of the assumptions and the ideas that we have about the world and the way we define degeneration and regeneration can be explored and transcended, in particular, by the use of visualizations. And so this morning I'd really like to explore some of these ideas by visualizing some of the data that's been made available from these new perspectives that we've been hearing about. So let's see. I'm curious, how many of you have heard of the Anthropocene? Okay, so this is a term proposed by geologists to describe the current geologic epoch. And it's defined by the impact our species is having on our home planet. Specifically, it's meant to indicate that evidence of our existence will still be present on Earth millions of years from now. So you can see here The Economist, the Global Change newsletter. This has been quite a buzzword within scientific circles recently, but you'll probably be hearing about it more and more. Because the geologic periods or the epochs are generally defined by the ability to see clear boundaries between the layers of rocks. And steam engines, the Industrial Revolution, nuclear explosions, highways, plastic, electronic waste, these are all leaving an indelible impression on the geology of our planet. And the notion of the Anthropocene captures the spirit of this ambivalent age. That, we have these modern conveniences that are making life much better for millions and billions of people around the world. And at the same time, we're seeing a rapid degeneration of many global ecosystems. And this is really not anywhere more evident than in the landscapes at a planetary scale. If we take these aerial photographs and start studying how we're understanding landscape from this kind of God's eye view, we can see the radical nature of these transformations. From the dense urban cityscape of Mexico City, to the desert towers of Dubai, to the industrial sprawl of Moscow, to the low-lying island cities, like this is the capital of the Maldives, which, as we all know, is in great danger because of rising sea levels, and the famous canals of Venice. And from this perspective, even seemingly mundane landscapes take on a new profundity, like the freeways of Los Angeles, housing developments in Las Vegas, Nevada, planned suburban neighborhoods in Florida, and the artificial archipelagos in Dubai. And of course, our agricultural systems are also transforming ecosystems and landscapes. These are polyethylene greenhouses in Spain, and helicopter irrigated dry farms in Spain as well. And if you ever fly over the US, you see these center pivot irrigation fields that dot the countryside and the landscape. But perhaps the most dramatic transformations, as was mentioned earlier, are the consequences of extractive mineral and energy industries. So these are oil fields in Texas, mineral mines in Western Australia, fracking sites in Wyoming, much of which you can't really see the consequences of these because it's miles and miles of pipes underground, to mountaintop removal coal mines in West Virginia, where they're literally just removing entire mountains as strategies for getting materials to burn. And of course, the wild boreal forests of Alberta that are being raised to access the oil sands. And the consequences of all of this can be seen in these familiar exponential curves of what's been called the simultaneous great acceleration of population growth, resource extraction and consumption, and ecological degeneration. So, resilient scientists have even quantified many of these critical thresholds of our planetary life support systems. Not just climate change, but biodiversity loss, ocean acidification, freshwater use, and many other interconnected issues. In their words, we're tipping towards the unknown, engaged in a high-stakes game of unwittingly crossing planetary boundaries that define the safe operating space for humanity. And according to the Global Footprint Network, we've been going into ecological debt every year at a planetary scale for the past 4 decades, exceeding the capacity of Earth's ability to regenerate the resources we're consuming. In short, humanity has become a geological force through its radical alteration of the Earth system. Yet, paradoxically, the notion of the Anthropocene also dissolves the dualistic distinction between human and natural systems, which raises a critical question. How did we come to think we were separate from nature in the first place? This hasn't always been the case. Many traditional cultures don't even distinguish humans from nature or even have a word for nature. They view their existence as being in reciprocal relationship with the continuum of life. Integral to this are practices and rituals of enchantment, in which humans view themselves as responsible for singing the world into existence. For countless generations, all of our ancestors their very survival depended on sustaining this relationship with patterns of the landscape. They developed countless techniques and practices for singing the living memories of their ancestral lands. And some of the oldest surviving examples, for instance, can be found amongst the Aboriginal Australians. Their song lines or voice maps that have been used to pass along knowledge of key waypoints for the past 50,000 years, including watering holes, hills, trees, food sources, all of these things across the landscape, so that as they travel across the country, they're actually passing along their memories. And rock engravings in Australia serve as reminders of the kindred spirits and animals that live amongst them. And they also serve pragmatic purposes. For instance, this is an outline of an emu carved into a rock, but it's oriented to the pattern of an emu in the sky, what they call a dark cloud constellation made up of the gas and the dust of the Milky Way. And it just so happens that when this pattern synchronizes with this rock, it's the time of year when emus are laying their eggs. And there are countless similar examples from around the world that we could talk about for hours and hours, like this Inukshuk in Hudson Bay, which are massive stone landmarks that are throughout the Arctic to signify the landscape, enacting cultural memories related to fishing and hunting, wayfinding, and creation stories. So these are really techniques, survival techniques, cultural techniques of creation of artifacts and rituals that cultures all over the world have used to build relationship with landscapes. But around 2,500 years ago, a new creation story appeared in ancient Greece that began to radically shift the Western relationship to the world and to nature. In Plato's Timaeus, he described the creation of the world by a rational architect whose mind and intentions the human intellect could comprehend. And through this, Plato imagined viewing the cosmos from the outside. He was no longer a part of the landscape, he was imagining it from somewhere else. And his student Aristotle built on this idea, describing a spherical geocentric cosmos, an earth-centered universe. He proclaimed that the earth was feminine and corruptible, made of the corruptible elements of earth, air, fire, and water, but it was surrounded by this eternal, masculine, heavenly sphere that was rotated by the hand of the Creator. And this supernatural vision was appropriated by the medieval Catholic and Protestant churches later on, replacing the cosmic architect of Plato with the Christian God. And they retained the idea that even though Earth was at the center of the universe, it was actually the worst place to be. Around 500 years ago, Nicholas Copernicus pushed this idea even further. Like Plato, he believed that the human intellect could know the mind of God. But he imagined this God's eye view from the perspective of our own solar system, looking back at Earth, and he said that it wasn't actually Earth that was at the center, it was the sun, the central fire. And the consequences of this move have become widely known as the Copernican revolution. And Thomas Kuhn famously coined the term paradigm shift to describe the subsequent impact of this heliocentric vision on the Western worldview. And this eventually resulted in the shattering of the heavenly spheres in the European imagination. There was no longer this distinction between the heavens and earth. It led to the so-called Copernican Principle, or the mediocrity principle, sometimes even called the cosmological principle in science. It's a really cornerstone idea within Western science. And that's the assumption that the entire universe is like Earth, that there's nothing special or unique about our home planet, that the same chemicals and laws that can be found here on Earth can be found everywhere else. And this is reinforced by the quantification of space and time made possible by new observational instruments like the telescope and new predictive mathematics that seemed very, very effective. The seeming external world of nature was increasingly objectified and mapped as a resource to be controlled, predicted, and exploited. And increasingly, it was believed that the best way to understand nature was by reducing it to its component parts. Reductionism. Get it? So this eventually led to ever-increasing disciplinary specialization and the fragmentation of knowledge. So it's why we see this extraordinary expanse of knowledge, but at the same time, everything's becoming more and more specialized, so it's very difficult for anyone to have a sense of the big picture. Which strengthened perceived dualistic divisions between subject and object, mind and body, and perhaps most significantly, humanity and nature. And as the earth increasingly became viewed as an expendable resource to be dominated, the widespread disenchantment of the world took hold within the modern world. Dreams of escaping to other more perfect worlds became a recurring trope within the narrative of modern progress. And amazingly, by the mid-20th century, the quest for this God's eye view became a physical reality. Humans achieved escape velocity from Earth just after Expo 67. This is what was in the dome, for those of you that were there, to celebrate the accomplishments of the Apollo mission. But as the space age took hold, it had unexpected consequences. When photographs taken by the astronauts began to be broadcast around the Earth, they profoundly altered visions of humanity's place in the cosmos. They appeared to show Earth as an interconnected system and provoked many questions about the humanity's relationship to our home planet. And these photographs are even often credited with giving birth to the modern environmental movement. Yet today, this once revolutionary perspective is now largely taken for granted. It's often seen, like with the case of Google Earth, as little more than a way to find our rooftops. How many of you found your own rooftops in Google Earth? Show hands, going to be honest? Okay. Or to navigate around our cities. I mean, and this is an amazing capability, but we can do so much more. The fruits of the space age are also giving us these increasingly dynamic views of previously invisible relationships. Today, a network of hundreds of Earth-observing satellites are helping us to understand our home in new ways. They're illuminating interactions of previously invisible phenomena. For instance, as the Earth formed, it cooled down fast enough to maintain a molten core at its center. And this essentially acts as a dynamo that generates a magnetic field that deflects the solar winds of the sun. So as we're being bombarded by these protons, our magnetic field is being blown back. And this was one of the first things that scientists discovered when they got together in the 1950s and started studying the planetary system as a whole. This magnetosphere, as they call it, keeps our atmosphere and oceans from being blown away by this constant blast of particles from the sun. By understanding this from this macrocosmic perspective, we're beginning to realize that studying the whole system reveals emergent properties that are unpredictable only by studying the sum of the reduced parts. And if we zoom out a bit more, we can see that Earth is in our solar system's habitable zone, or a Goldilocks zone. It's just the right distance from the sun so that it's not too hot, it's not too cold, the temperatures are just right to support abundant liquid water. And this is what's being looked for in other solar systems when we're trying to find habitable planets in other places. But this is only one condition where the planet's surface could sustain water. Does this look familiar to everyone? It's the solar system, right? Right? I mean, you look up solar system, this is what you see. But even this classical view of the solar system is outdated by centuries. Just as we're orbiting around the sun is orbiting around the galactic core of the Milky Way at tens of thousands of miles per hour. This perspective reveals a dynamic, relational cosmos, that our world is constantly moving around with the rest of our solar system, and we're actually all astronauts aboard this kind of watery living spaceship. And the only reason that we're here is because of all of these different synergistic conditions and relationships of cosmic and planetary ecosystems. And from a cosmic perspective, nothing's drawn this point home more than what's called the Digital Universe Atlas. This is a NASA-funded cosmic model curated at the Hayden Planetarium from astronomical data sets all around the world. And here we're seeing trajectories of the satellites that we saw earlier. As we start to zoom out, we're going to go at incredible speeds so we can see the moon's orbit, the trajectories of all of the other planets around the sun. To a light hour, we see our solar system. The constellations come into view, but as we zoom out, we see the actual relationship of the stars' distances in the constellations. The lines collapse. We see the radio footprint of Earth in space, our own galaxy with hundreds of billions of stars. All of these other dots represent other galaxies, hundreds of billions of stars in each dot, to the places that we can't even see yet, all the way out to the edge of the visible universe. The cosmic microwave background, or what's called our cosmic horizon in time and space. Got that? So, what's truly amazing about this, though, is that you won't really find the biggest news of our generation in any headline. And that's that Earth is at the center of this new cosmic model. Kind of weird, right? So there's a couple of reasons for this, but the main reason is because of relativity, and scientists call it our observational center, because light has a speed limit. Wherever you're looking from looks to be the center, right? So wherever you're taking observations from, that would be the center. But more importantly, what we've actually found out is that Earth is the ecological center of our universe. As we've explored other worlds, we haven't found more perfect places for life. We actually haven't found any other places that support life. And this was not the expectation in the 1950s when the space program was instigated. And this is truly the unexpected paradigm shift of the space age that we're still working to absorb. By visualizing previously invisible patterns and relationships, we can now start to gain a greater appreciation of the synergistic conditions that support life on this planet. For instance, satellite observations of surface flows and wind currents show how fresh water moves in these kind of vortice patterns in the ocean and within the atmosphere. And ocean currents distribute solar energy to regulate the Earth's climate. Planetary temperatures are equalized by cold air and surface waters moving towards the equator, while warm air and water move towards the poles. And this circulation of the ocean sustains the necessary conditions for life as we know it. And it's also why Europe can be so warm, because we have these currents that are actually redistributing the solar energy within the oceans. We can also visualize flows of life on the planet. This is just one example among many, 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 but these yellow data points represent the migrations of storks on the way to Europe to reproduce after they've been wintering in Africa. We can also see how the topography of planetary landscape affects the atmosphere. Much of the intense flows of black carbon from industrial pollutants in India, for instance, are trapped within the subcontinent because of the height of the Himalayan mountain range, which you can see here. But the black carbon also mixes with other particulates in the atmosphere, particularly within hurricanes, which we can see going across the Atlantic Ocean here. They include dust emanating from deserts, particularly the Sahel, sulfates from fossil fuels, volcanoes, and the blue is actually sea salt from ocean evaporation. And by visualizing these remarkable interactions, we can see why it's so important that as we consider the design of civilization, we really should be doing it with the idea of Earth's life support systems in mind. So one person who anticipated the urgent need to visualize these invisible flows was the American polymath Buckminster Fuller. So most people kind of know him as that dome guy, and in Montreal, I'm sure he's mostly associated with the biosphere, but he insisted for many, many years on the importance of understanding and studying the whole system, since its emergent properties and synergies are unpredicted by the sum of its parts. So back in the 1920s, he began visualizing what he called the one-town world. He was concerned that our political boundaries were obstructing our understanding of ourselves as a planetary species and the interconnections amongst our planetary system. He collected data about global trends for decades, detecting the beginning of the rapid acceleration of many of the phenomena that we saw earlier in those graphs, but these were actually done in 1940. So he was just starting to detect this acceleration was happening. And he worked with students to develop an inventory, a comprehensive inventory of what he called world resources, human trends, and needs. And he proposed that these data sets be displayed on a 200-foot diameter mini-Earth outside the UN. This is a drawing from 1956 that would show visualizations of transportation, world population, development, distribution, and redistribution of resources. And his goal was to remind the international delegates at the UN of our common fate as a species. So we started building numerous prototypes in the 1950s of this geodesic display structure, working with architecture students around the world. They anticipated that eventually computers would be able to control lights on its surface to dynamically illuminate these invisible planetary systems. And this was actually precisely what he proposed for the US Pavilion at Expo 67. He proposed to the US government that the dome be covered in 100,000 light bulbs controlled by computers in the basement that would dynamically visualize all of Earth's invisible relationships. And that visitors be invited to play what he called the world game, in which they would be challenged to design a world that would work for 100% of humanity. But this proposal was rejected by the US government, and to be fair, it was a little bit ahead of its time. Computers at the time weren't quite up to the task. So they opted instead to show off the material about American pop culture, about the Apollo mission. And years later, in 1976, as we all know, the workers' torch set the dome's acrylic covering on fire, but the geodesic structure was intact, and it became an icon for Montreal. I've always been waiting to use that transition. Never again. But Fuller's dream of the geoscope has yet to be realized. But today, his ideas are actually more relevant than ever, 50 years later. In his 1968 book, Operating Manual for Spaceship Earth, he insisted on the importance of comprehensively designing for the entire Earth system. He had a chapter, and it actually called Regenerative Landscape, in which he called on architects, planners, and engineers to take the initiative to study the synergistic principles employed at every scale by evolution. And in the past 50 years, this has really started to happen. Studies of the interconnections between Earth's nested systems reveal that sustainable development is not simply a matter of doing slightly less bad. It's essential, well, we can see here. So we kind of think along this continuum, right, of indiscriminate resource use, more efficient resource use, conserving resources. The question is, what are we talking about when we talk about sustainable development? It's essential to apply strategies that really establish a reciprocal relationship and apply these evolutionary design principles in a way that we can actively participate in the regeneration of the biosphere. And these types of strategies are precisely what we're looking for at the Buckminster Fuller Institute. For the past 8 years, we've been giving away a $100,000 prize looking for projects that meet the goal of Fuller's World Game, which was to make the world work for 100% of humanity in the shortest possible time through spontaneous cooperation without ecological offense or the disadvantage of anyone. Which might sound kind of crazy, but we're finding really interesting stuff. The first year's winner was Dr. John Todd in 2008, who developed and refined over many decades what he calls eco-machines. And these are constructed ecosystems where he mixes bacteria, plants, fungi, animals to ecologically clean toxins from water. The image on the left here is one of these eco-machines at a chicken processing plant. which has 250,000 native plants and treats 1.5 million gallons of wastewater a day. The image on the right is from Fuzhou, China, which treats 750,000 gallons of raw sewage a day. This winning project is a strategy for cleaning up the so-called slurry impoundments in Appalachia, in the mountains of Appalachia, in West Virginia and Kentucky. These are the massive toxic lakes resulting from mountaintop removal coal mining. Another example of this kind of regenerative approach is the Savory Institute, our 2010 winner, and they're addressing the literal roots of social and ecological degradation worldwide, pointing out to heal the planet, we have to heal the soil. Because grasslands around the world are actually key to economic and food security, but they're rapidly becoming deserts. So after studying the evolutionary relationship between livestock grazing and soil for decades, Savory developed this method that he calls holistic management, a way of managing livestock in a way that mimics the evolutionary patterns so that the animals can move around, they can trample the soil, and they can actually start to regenerate the soil quite rapidly. Just a few before and after pictures, which this is seemingly counterintuitive. I mean, I've been a vegetarian for 30 years, so when I heard that you introduce livestock to regrow grasslands, it blew my mind. But this practice has successfully reversed desertification on millions of acres of land worldwide. And this other view of the NASA visualization that we saw earlier shows the dust from desertified areas, particularly in Africa, profoundly affects the global atmosphere. And as an added bonus, healthy grasslands sequester carbon. By the Savory Institute's calculations, if 1% of the 5 billion hectares of global grasslands were regreened, the ones that are becoming desertified, that it would bring down atmospheric carbon dioxide by 135 parts per million to pre-industrial levels. And tomorrow morning, you'll be hearing more about the latest winner, Living Breakwaters, which is a visionary project in New York that demonstrates the critical importance of landscape architecture in connecting culture, ecology, and social resilience, particularly to reduce risks within the context of a rapidly changing climate. Which brings us to the theme of the Congress. In 1965, landscape architects from around Quebec got together for the common purpose of enchanting Montreal and the global community by celebrating man and his world. So 50 years later, this Congress has been convened to examine the role of landscape architecture for the next 50 years. And as the boundaries between humans and nature, between human systems and natural systems, which are sometimes called social ecological systems now, dissolve, it's essential that we find more effective ways of actively participating in the restoration and regeneration of global ecosystems. Because if the space age has shown us anything, it's that we're all indigenous earthlings, and that we take the conditions for life for granted at our own peril. We now have the opportunity to reimagine humanity's reciprocal relationship to Earth from this big picture perspective, but it's up to every one of us to take on the responsibility this implies. If we want to actively participate in the regeneration of planetary landscapes, it's got to begin by falling in love with this planet and re-enchanting the world. Thanks.